Welcome everyone. Like I was saying, today we'll be looking at a few problems dealing with mainly integration, and most specifically integration by parts. We'll cover a few problems, and since you guys are slowly introducing the topic in your lecture sessions with the different lectures and the tutorials as well. I think we'll try to take it as easy as we can, so we don't overwhelm you guys with too much information. So what we'll do is we'll start with the first question here, and it's looking at the integral, right? So we're looking at the integral of the square root of x times cos inverse of the square root of x. So, right, this is the type of integral that is, as you can see, is not particularly easy to solve using the other methods that we know of, right? So that's where integration by parts comes in. So in your opinion, based on the formula for integration by parts, what should be our u and what should be our dv? I'm asking you. Right, so take a moment, think about it. We have two functions, right? We have the function square root of x, and we have the cos inverse of cos square root of x. Sorry, the cos inverse of square root of x. So which one of these two functions do you think should be our v, and which one should be our dv? And remember that integration by part tells us that when we have a function of this form, this is how we solve it. That's the formula. And so in that case, which is our u and which one is our dv?
dv is root x.
Sorry?
U is dv is root x.
Root x, dv is root x.
Yes.
And u is?
U cos root x.
Right, so let's try that. So u would be r cos root x. Thank you. So let's try that. In that case, then our du would be the derivative, right, of arc cos of root x in terms of x, right? So what does that give us? Well, that gives us the derivative of arc cos root x divided by the square root of 1 minus the square root of x squared, right, dx. And this gives us that du is therefore equal to, right, yeah, it gives us that du is therefore equal to negative 1 over 2 root x, right, divided by the square root of 1 minus x. And our v, we had our dv was the square root of x, so our v will be 2 over 3 x to the 3 over 2. Right. So there's a dx missing there. So then, looking at our formula, our uv, so the integral, which was u dv, is now equal to uv, right? So what is our u? What's our v? our u is our cos, and our v is 2 over 3 x to the 3 over 2, that multiplied by cos inverse of the square root of x, minus the integral of v du. So that would be 2 over 3 x to the 3 over 2 times du, which we found to be negative 1 over 2 root x divided by roots of 1 minus x dx. Now let's see if we can simplify this expression any further. So this would just become 2 over 3 x to the 3 over 2, right? Multiplied by arc cos of root x minus, right? So that would be minus minus, so that would be plus there. The integral of, and maybe to simplify the expression as well, we'll take out the constant. So we have 2 over 3 here multiplied by the 1 over 2 here. So that would give us 1 over 3 that comes out of the integration side. And what we're left with here is x to the 3 over 2 divided by a root x multiplied by 1 over root of 1 minus x, right, dx. And simplifying this further, we have 2 over 3 times x to the 3 over 2 arc cos of the square root of x plus 1 over 3 multiplied by the integral. If you simplify the x here, you have x over the square root of 1 minus x dx, right? So now we have this integral to worry about, right? So let's solve it separately. So we have the integral. So we have the integral here, right? Of x over the square root of 1 minus x dx. In your opinion, how should we solve this? Any suggestions? Right? So as you can see, to solve this, we can use one of the methods that we used before, which was u-substitution, right? So just not to confuse with the u that's there, let's call it a substitution. So let's a be equal to, right, 1 minus x. dA is therefore equal to negative dx, right? And when you substitute that into the expression, you have x, which will now become 1 minus a, right? Divided by the square root of a multiplied by negative dA, right? And this will become, if you simplify this further, it will become u minus 1, or rather a minus 1, sorry, multiplied by a to the negative 1 over 2, multiplied by dA. And you integrate this, you can multiply the factor a to the negative 1 over 2 into the expression, and what you get is when you're done integrating, of course, what you get is a to the 3 over 2 over 3 over 2 minus 1, sorry, not 1, minus a to the 1 over 2 over 1 over 2, right? And this will be equal to, therefore, 2 over 3, a to the 3 over 2 minus 2, a to the 1 over 2, which if you combine, if you substitute the value of a and combine with the original expression, then you'll find that our integral, right? So our integral is therefore the square root of x, right, multiplied by cos inverse of the square root of x dx is therefore equal to 2 over 3 x to the 3 over 2 arc cos root x, right, plus 2 over 3 multiplied by 1 minus x to the 3 over 2 minus 2 into 1 minus x to the 1 over 2. So this should be the final answer. I'm not sure if you can simplify it further, but you guys can always play around and attempt to see if you can get any more simplification from there. Right, so any questions? Any questions? You are more than free to stop me at any time and ask questions if you have any. Right. So moving on, let's look at the next question. Right, so this next question here is giving us the integral from 1 to 9 of 1 over x minus 1 to the 1 over 3 dx. Now, suggestions. What should we use to solve this question? Right, so I think I can suggest for a question like this, you can try to use u-substitution, right? So you can say let our u be equal x minus 1, right? Meaning that our du will be equal to dx, right? And therefore, if you substitute that back into the expression, you have the integral from 1 to 9 of du now over u to the 1 over 3, which you can easily integrate to be u to the 2 over 3 divided by 2 over 3. Evaluated between 1 and 9, and if you substitute back the x, you have x minus 1 to the 2 over 3 divided by 2 over 3, right? And if you evaluate this in between those boundaries, what you should get is substitute 9 first, so you have 9 minus 1 to the 2 over 3 divided by 2 over 3 minus 1 minus 1, which is just 0, so 0. So you have now 8 to the 2 over 3 divided by 2 over 3. And you know that 8 is 2 cubed, so you have 2 cubed to the 2 over 3 divided by 2 over 3. And this can just be simplified to be 2 squared divided by 2 over 3, which is 4 divided by 2 over 3, which is 6. Right, so just double check that. Yeah. Right, so that should be your final answer. Right. Any questions there? This one was a pretty straightforward. Right. So this one was more of the simplified examples. And as you can see, the steps taken to solve this are very small, right? So it's a very straightforward sort of example. But if you are tempted to use integration by parts, you just don't know how long it would take you to solve this. So you'd rather try to see, and as I've said, I've mentioned before, it's really a trial and error thing. So you need to try it multiple times and see if it works out. So you have to try different methods and see which one is giving you the best results, or rather the shortest way to the solution, right? So, and the only way you can know that really is by practicing. So let's move on to the next one and see what we have. Let's see if we can apply the same logic here. Well, for this one, we have the integral of sine to the 5x times cos to the 4x dx. So in your opinion, what do we do here? I'm asking you guys. I want your inputs on this. How should we go about solving this? If I'm not mistaken, there's a section that you guys have dealt with more recently about the integrals of the product of two trigonometric functions. So keeping that in mind, what sort of suggestions do you have for a problem like this?
How about we split sine into squares?
Oh, okay. So that would mean we substitute sine. So sine, we know that sine squared of x is equal to 1 minus cos squared, right? So we can use this, for example. And sine squared squared, which is sine to the 4, right, is therefore this squared. So let's use that. Let's split the sine. So you have sine squared x squared again, multiplied by sine x, multiplied by cos to the 4x dx. Hopefully you guys are following up to that point. Then you substitute this by the expression that we have there. So you have 1 minus cos squared x squared multiplied by sine x cos to the 4x dx, right? So we have that. Now, next, right? The next, we can simplify the expression further. We would have sine x cos, oh, rather, sorry. First, we need to expand that square there. So we have 1 minus 2 cos squared x plus cos to the 4x multiplied by sine x times cos to the 4x dx, which will give us, when we expand, will give us sine x cos to the 4x minus 2 sine x cos to the 6x plus sine x cos to the 4x dx. Sorry, not 4x, that would be 8, right? So because it's cos to the 4x multiplied by cos to the 4x there. So that's cos to the 8 dx. So now that we have that, we can integrate these separately. So we have 3 integrals. Break them down into 3 integrals. Sine x cos to the 4x dx minus 2 multiplied by the integral of sine x cos to the 6x dx plus the integral of sine x cos to the 8x dx. Now, if you evaluate this, and you can use substitution again. So let's use for the first one, and then we'll just apply the same logic to the others. Right. So for the first one, which is this one, if we apply the logic that we can use some sort of u-substitution to have let our u be equal to cos x. Our du is therefore negative sine x dx. Applying that, we have that the integral of sine x cos to the 4x dx is equal to the integral of, right? So u is cos x, so u to the 4 multiplied by sine x dx, which is negative du. Right. And this is equal to negative the integral of u to the 4 dx, which is negative 1 multiplied by u to the 5 over 5, which is just minus cos to the 5x over 5. So that's for the first integral. Now applying the same logic to the other integrals here, we'll have that the final integral, which we'll just rewrite. So let's just rewrite this thing. The integral of sine to the 5x cos to the 4x dx is therefore equal to, right? So this first integral here, negative cos to the 5x over 5, right, minus 2 times so minus 2 times negative, right, cos to the 7x over 7, right, minus, or rather plus, minus cos to the 9x over 9, right? So we're just using the same logic we used there. So this expression can therefore be simplified further to be 2 over 7 cos to the 7x minus cos to the 5x over 5 minus cos to the 9x over 9. Right? So this is what the final answer would look like. Now, any questions at this point? Any questions, suggestions, any comment at all? I'll give you guys maybe 2 minutes to have a look at how we solved it and see if you have any questions. All right. There doesn't seem to be any questions at this point. So let's move on and see how the next question can be solved. Right, so the next question is asking us to find the integral between the square root of e and e of ln x over x squared dx. So now this one here, obviously we can see that we can't simplify this any further, right? Ln x is just ln x, x squared is just x squared. So immediately we try to see now, how can we use u-substitution, or rather not u-substitution, but integration by parts to solve this. So if we go back to our formula for integration by parts, which was the integral of u dv, which is uv minus v du. For the specific problem, what should be our u? What can be our dv? Suggestions? I want you guys to speak. Any suggestions at all?
How about we let ln x equal to u?
Let ln x be equal to u. Okay, let's try that. Let's see if it gets us to the answer. If we let ln x be equal to u, then our dv will have to be 1 over whatever's left, so 1 over x squared dx. Meaning that our du will be equal to 1 over x dx, right? And our v will be equal to the integral of 1 over x squared, which is just negative 1 over x. So now that we have our du and our dv, and our v, sorry, we can introduce this to the formula. So the u dv will therefore be equal to u times v, which is negative 1 over x times ln x, right? Minus the integral of v du, which is negative 1 over x multiplied by du, which is 1 over x dx. Simplify this. Let's see. We have negative now 1 over x ln x minus minus, so that's plus the integral of 1 over x squared dx, which is therefore equal to negative 1 over x times ln x, right? Plus the integral of 1 over x squared, which is just negative 1 over x, right? So therefore, if we evaluate this between the boundaries that are given to us, so our integral, which was the integral from square root e to e of ln x divided by x squared dx, was found to be negative 1 over x ln x, that would be minus now, so minus 1 over x, and this is evaluated between those boundaries. And if you substitute in, you will see that you have to start with the upper boundary, so you would have negative 1 over e multiplied by ln e minus 1 over e, right, minus the second bracket, negative 1 over square root of e multiplied by ln of the square root of e minus 1 over the square root of e. Let's simplify that. We have negative 1 over e times ln e, which is 1, so that's minus 1 over e minus that would be plus now 1 over the square root of e times ln of root e, which is just 1 over 2. So 1 over 2 multiplied by 1 over 2 there, minus 1 over the square root of root e. Simplifying further, these two are common, so we have negative 2 over e. And these two are common as well, so that should give us plus, or rather minus, sorry. That would be minus 1 over root e. Oh, this is my mistake as well. There's a minus here and a minus there, so this should be positive now. So plus. So this should be the final answer. So now this means that the substitution that we chose for our integration by parts did get us to the final answer. So now my question is, what if instead we chose to use let u be equal to, right? Let u be equal to 1 over x squared, and we let dv be equal to ln x dx, right? Because that's the substitution the other way around now. Now, we would be able to evaluate our du to be what? Our du would just be the derivative of 1 over x squared, which is negative 2 over x cubed, right? But then our v would be the integral of ln x dx, which is not an easy, straightforward integral to find. So we would have to use some sort of substitution as well there, right, to find this integral and then come back to the original question, right? Which, as you can see, can get us to the final answer, yes, but it's going to take way more steps than this, right? So again, I'll repeat it. The way you choose your functions, u and dv for integration by parts has a very big impact on how long you take to solve the problem, right? So some choices take longer. They still get you to the final answer, but it takes a little bit longer, and others are a little bit more fast. So pay attention to that when you are solving problems. Try to stick to substitution that would make your life easy. And when you see a problem like this, you can immediately realize that ln of x is not an easy function to find the integral of, right? It's not. Meaning that if you chose it to be the function that you had to integrate, right? So that dv, that would be a choice that would make your life harder, not easier. So it would make more sense to choose it as the function that you have to derive, because that's a very easy function to derive. We know that the derivative of ln x is just 1 over x, right? So that's the thinking that you should always keep at the back of your mind. Right. So, any questions there? I'll give you a few minutes to think about it. If you have questions.
Sir,
Yeah.
there's this acronym from the book that is called LIATE. They said we should use it for the selection of U. I saw it from the book.
Right. I'm not particularly familiar with that one, but if there is, right,
Yeah.
then try to use it and see if it makes your selection easier. Thank you for that.
Yeah, I just want to
If,
recommend it to others. They should check it.
yes, definitely. Thank you so much. Please also maybe in the chat box maybe send the reference, like the page or the chapter under which you found that particular method.
Okay, I'll check it.
Because that is definitely a very nice a very nice method to sort of make these choices a little bit more simple to make, right? Because if you think about it, when you're working with multiple questions like this, and you need to make very quick sort of decisions in terms of which function is u, which function is dv, you can quickly, if you have a method that sort of makes the selection easier for you, then That's that's a method that you need to know, right? You need to know, because like I said, it's not magic. You can't just magically know which one will take less. But if there is a method that's proven and that's been tried before, then you should always have that in